So we have our graph of our derivative, which we'll rename v of t because it's a graph of our velocity. And what we see is our velocity is always either positive or 0, and our velocity is increasing from 0 to 1, decreasing from 1 to 2, 0 from 2 to 3, increasing from 3 to 4, decreasing from 4 to 5, 0 from 5 to 6, and then that pattern seems to repeat. So we can draw a graph of v prime of t. Now, first thing we'll do again is mark all the places where it's 0. So our velocity is going to have a derivative of 0 here at 1, and then it's also going to have a derivative of 0 here from 2 to 3. Let's use a different color as we're doing a different graph. From 2 to 3. It's going to be 0 again here at 4. And then from 5 to 6 again it's 0. So we're going to have a pretty interesting looking graph. Actually from 5 to 7, excuse me. But we're going to have a lot of repeats, so if we can get the first one we'll be able to draw the rest. 0 again here at 8. And then 0 again from 9 to 10. So the big question is what's happening now in between those? Well, our velocity seems to be at a maximum somewhere in this area, in between 0 and 1. It's probably pretty symmetric, so we'll say at a half of a minute our velocity is at a maximum. So we need that slope. So once again, using our ruler, it looks like we're going up about 4 units of velocity, so thousands of feet per second, thousands of feet per minute, excuse me, in 1 minute. So it looks like it achieves a maximum of 4 at a half. So let's use the same scale. 1, 2, 3, and then that would be 4. So it's going to hit a maximum of 4 there. Now similarly, at 1.5, it's at its steepest negative. So again, we're going to use symmetry. And so it's going to, at 1.5, hit down here at -4. So our graph is going to do something along the lines of up to here, and it's going to be positive because the velocity was increasing, and come back down and hit 0. Come here and hit our point, and go back up and hit 0 again. Okay, the graph would be a lot smoother if we were able to draw this, if we were drawing this with technology. And now again, we're going to see, like with the first derivative, the pattern repeated. Come up and hit this point, come back down and hit this point. And that's going to happen again here. It's going to have a max and a min at 4 and -4. Comes up and hits, comes down and hits. So we're paying attention to the same things we did to in previous sections. For instance, where our function is increasing, our derivative should be positive. Where our function is decreasing, our derivative should be negative. Where we have a turning point, our derivative should be 0. Now what we've drawn in this green graph is actually the graph of the acceleration of the car. Because what's happening is we're speeding up, we're increasing our velocity, so we're accelerating. We got a positive acceleration. Here we're slowing down, we have a negative acceleration. So we're seeing the same relationships between this graph and this graph as we did between s of t and s prime of t, which we're calling v of t. Now v of t is what we would call s double prime of t, or the second derivative of our position function. And that's what we're going to be looking at in this section, is second derivative.